Good day, viewers of the DP Labs channel. My name is Kirill, and you're watching a new episode about the electric ATV. We started the rear subframe with the purchase of the differential, which we talked about in the first episode, as well as the drive shafts, knuckles, and other components. Basically everything that connects to this differential. Next, we started thinking about how to mount this differential to the ATV frame. This part is quite complex in terms of geometry. And drawing it out just using a caliper was a task that, while probably technically feasible, really wasn't very rational. So we decided to scan it and, based on the 3D scan, started building a model of the rear subframe by hand. Here, the differential is aligned according to the planes. Next, we add the plates that make up the entire subframe. Just here, we have the engine and the precise point where it connects to the differential. Initially, we considered making this subframe out of steel, since the mounting tabs and other thin, delicate elements seemed too fragile and intricate to make from aluminum right away. But overall, as an experiment, we decided to manufacture it from aluminum after all, which is a lightweight yet durable material. We also added some additional reinforcements and accordingly plan to test it thoroughly in its aluminum form. The rear subframe, which contains both the differential and the engine, looks like this on the model. So, in front of you is the metal part itself. In our case, it's AMG3 with a thickness of 4 to 5 millimeters depending on the part. These parts make up our rear subframe. Its function is quite simple. It securely holds the differential, the control arms are firmly attached to it, the motor is carefully mounted on it, and the entire assembly is then attached to the main body of the ATV. It also extends beyond the sealed enclosure, meaning it is not sealed, but it is made to be as dust and dirt resistant as possible. In other words, large chunks of dirt, such as pebbles, simply can't get inside. They won't clog up the internal spaces. Everything is completely covered. So if water gets in there, it's not a problem at all. Sealing is done at the engine shield. The engine is mounted here with a gasket, and the shield itself is attached to the body using sealant. Next, we'll show the preliminary assembly of the rear subframe. A few words about the repairability of this unit. Most of it is welded. In the second version, even more individual parts will be welded right here in this area, but at this particular stage, it's still just a few components. This wall can actually be removed entirely. So here the connection is completely bolted, and you can detach it together with the suspension if you need to replace the differential or work on the connection between the differential and the motor. Also, the differential assembly may sometimes need to be removed in order to properly replace the oil seal located on the output shaft. And the outer oil seals are accessible without any disassembly. Just remove the drive shafts. For now, we don't have any bushings pressed in here, since the control arms are going to be painted and the bushings will be pressed in afterwards. So we'll just loosely put them in place for the overall picture. Let's go have lunch together right now. Is it a bit heavy for someone, or is it just me? There's no one here, guys. Go ahead and grab some delicious tender chicken. Well, I have to admit, I already like it much better this way than before. Oh, it seems that the attentive gods of YouTube have truly listened to the voices of our commenters. Now, right here, we have both the much requested windows and in addition, a little bit of carbon, just as people have been asking for. Huh? The maestro helped. Let's take a look. No way. The weight is 40% less. Now that's beautiful. That's luxury. All that's left is to finish it. So in this episode, we went from a mock-up to a metal product thanks to computer modeling, 3D scanning, and of course, our ingenuity. Now we have a pre-assembled rear subframe. There are no bushings here yet, and the ball joints haven't been pressed in, since the part will be painted. Specifically, the subframe will still undergo several modifications that we identified during assembly. Accordingly, for the convenience of future assembly, we immediately make these changes to the drawings, and later we'll be assembling what is essentially its second version. The overall architecture is as follows. By analogy, we will design the front subframe in the same way. We don't yet know for sure how viable aluminum will be in this component, but we want to test it. Since the weight of this subframe, the entire structure, is only 6.5 kilograms. Accordingly, if it were made of steel, it would weigh about 20 kilograms. So the difference is quite significant. We want to test it, maybe add some reinforcement, but most likely we'll still end up with a weight advantage. At the moment, we see weak points at the silent block mounting locations. Since aluminum is a soft metal and the silent block could turn inside it, that's why we'll add steel washers here, meaning they'll go into the aluminum with a larger diameter and be clamped in place. But overall, the design is carefully thought out and carefully designed, and everything fits together very well. As you saw, it's actually pretty quick. Next up is painting, assembly, and testing. Watch the next episodes, subscribe to the channel, like the videos, and leave comments, especially thoughtful ones with advice and tips. We always appreciate that. We read all the comments, so we'll be grateful for any help.